Hi guys, I'll be showing you how to set up our environment, and we will go through everything that we did in Classroom last Tuesday. So first of all, just go to your email. You must have received an invitation to Dropbox from me to this folder, 6870. Once you go there, you will see our workshop. Click on it and you'll see a lot of data. Do not take the data from here, but create a folder and name it this, ITLS class. Once you create that folder in your own Dropbox, copy the following files to your folder. Copy, make sure not to drag this out. So copy the do not panic non-numeric, copy do not panic numeric data. Also take out NYT1, not the small one, but just NYT1 CSV. Then both UFO files, update new and just update. And I think that should be it. So once you copy it over to your folder, close out the Dropbox, and start the R Studio. Make sure not to start R, but start R Studio. When you open it up, it should look something like this. Okay, once you do that, you go to this little icon right here, not the drop down arrow, but this icon. Click on it and it'll open it where you want to go, where you want to find your file, which should be your Dropbox, and your folder name should be not 6870 but your ITLS class. But right now for mine, I will be doing this 6870. Go to the file that says don't panic non-numeric and click enter or open it up. Make this window a little bigger so you can see. So now you'll see four environments, four windows. This first one is your script window, where the code, our code, is located. This one is the output window. When you run something in the script window, you'll see it right down here. This right top one is, it will show you where your files are. Right now I'm connected to Git repository. Yours might not have that. You have the history and then you have the environment. So go to the environment and stay on the environment tab. At the bottom, right bottom, you have files. All your files you have read in before, or the location. I have home, documents, work, and your path will be probably your Dropbox path. Plots will be when you plot something in a script, for example, histogram or bar graph, it will show right in here. Packages, it's whatever you have already installed on your R Studio, and we will go through this one later, but I have already these marked ones, checked ones. Then help, usually if you have a question about a certain command, a certain code script or anything, usually if you type the name here, it will bring up the help. And then the viewer, we don't need that right now. So go to the plots on here, environment on this, and then the script here. First of all, we finished already the first step. We set up our environment. But to go to the step 2, before going to step 2, we need to go to sessions, right here. Click on it, set working directory, and do to source file location. What this does is makes sure that wherever you got your file, the script file, that's where your working directory is, since that's where also your files are. This way you don't have to every time tell RStudio where to go find the file, and you don't have to type up the whole path. Now step 2 is RStudio is an environment where you can run R code, but for that you don't have to reinvent the wheel, but you can just go directly install packages that other people have written already and just use their commands, their functions, instead of writing up the whole function yourself. So from this whole script that we have done in class, we actually went halfway because it took a lot of time. We understood that we need these 3 packages. You can run this command by just clicking anywhere on the line and doing run. First time you do this, it's going to ask you this question. I usually do no because it'll take you forever if you say yes. So just no. And you see this little red icon popping up here, which means that RStudio is working on your command. So do not do anything else while it's showing. Right now it disappeared and showed this downloaded binary packages. So which means my command was successful. It downloaded all the packages I need. If this does not work for some reason for you, you can go to Tools, then go to Install Packages, and then type up manually the names of the packages right here in green without quotation marks. And then it will show you the options and you can just do install. So once you're through with that, usually you don't have to do it if you run this line. Also, you can double click on the line and then run it. So select the whole thing and run it, or just click anywhere on the line without selecting a couple things, just anywhere, and run it. It will run the whole line. This portion in green after the hashtag means that's a comment, so it won't affect your code, or it won't affect your command at all. It's just there to explain what it does, and you can go ahead and read these things to understand what's happening, but I'm explaining you. So the next thing is step 3, which is renaming our file. First one we'll work on is the UFO update file, which is the UFO file that we worked already on last previous Tuesday, the first Tuesday we worked. So what you do is you come up with a name. This can be any name you want, but right now I'll just work with mine because I use it throughout the script. You come up with a variable name and then you assign it to this data file. We are doing read.csv because our data file is CSV. If it was an Excel file or a TSV, we would have something else here. Not necessarily always TSV instead of CSV. There are different commands and you can look it up in help. So click anywhere and run it. And then again, you see this stop sign. Do not touch it and do not do anything else while it's showing up. If it takes forever, then click stop, which means that RStudio is having a hard time running your script, so you should probably stop it before it crashes. But right now it just takes a couple seconds. And you can see right here in our environment appears this line, which is our data file and our variable name. And it says how many observations there are and how many variables, which is the columns. So double click on it, and then it will show your data file. Okay, you can see all the columns, column headers, and you can scroll over and see everything till the end. And then you can scroll down and see the data file. Of course, this environment is not going to show you all the rows, which is more than like 60-something thousand. So it will show you just only selected first 1,000 of it, and which is fine. So you close that out. And you can get to it anytime you double click on this environment, not on the arrow, but just anywhere on this line. Okay, so the step 4, we usually attach the file because in this environment to reference like a certain column from your data file, you need to every time type up the name of the data file, this variable, then put a $sign, then whatever column you want. Just to get rid of that whole mess, we just attach the file. This way, it knows that whatever command we do, it's talking about this data file, nothing else, just this data file. So it will try to match it up and do the command without having to have the whole path to this file. So once we touch it, we go to step 5. Here, our data file is very big and considerably big, and it is hard to manually go through it and see what kind of issues we have with the file. Initially, we have, as you can see, we have several columns that need to be separated. So we have this column called city_state, which should have been separated, which we did actually. If you scroll all over, you see the city separately, and then you'll see the state separately. We did it with Excel command formulas, separating whatever it is after the comma into the state and whatever is before the comma into the city. Well, while the first couple thousands show just perfectly fine the results, we can't rely on what we see, so we have to double check it. Therefore, we do step 5, which is unique, and then the name of the column we want. Right now, I thought about doing state, so I typed it up. When you run it, you will see the output shows every single unique state. It's not going to show you the same state a couple times. It's showing you one time only, unique. The first couple lines you can see everything is fine, but then later on you notice there's a state R and comma, there's a state dot and comma, there's a state question mark and comma, which is wrong. So therefore that just gives you an idea that your data file needs to be cleaned. But this is just how it is to work with big data files where you can't manually go through them. You can try the same thing on your own, and you can try a different column, or you can come up with a different function you want to do. R is very close to English language, so you can think of whatever you want to do in language and just look it up. And for easy access to R information, you can go to the, I thought I provided, yes, this website, R related questions. You can go there, you can do quick R, and you find all the questions. In reality, you can just Google it. Really, it's easy. Just make sure to type R or R Studio, and I'll give you the answers. Okay, so to see the summary, first you do the summary of the year, and you can see that we have median, mean, and max, and mean, the lowest. This already is wrong because you can see there's a year 0. We don't have such a thing. We can see the median is 1992, and that's where we understand that there is a difference between non-numeric and numeric data files, and ours is non-numeric. You can't really do a mean of the years. Maybe median makes sense, but mean does not quite make sense. So this is just a quick way of like exploring your data file. Then you can do the head and see the top ones. Also, you can just do the head of your file and see whichever the first ones come up in the data file itself. This is in order of the rows that the actual data file shows up. Next, we can do frequencies. So we can read in the second file that I cleaned up a little bit. Right here, we assigned it to different variable. Again, the stop sign appears. And make sure not to do anything else while the stop sign is still there. And you see right here a new data file appeared in an environment. This is called my data new, and it has the same data itself, but it's just cleaned up a little bit. Then we attach the file again. By the way, if we change anything in the code, if we type anything up, this is going to change, saying that there is unsaved changes in the file. If you're sure about it, you can save it. I do not want to save it right now. I'll just go through it. But make sure if you're working on your script, constantly save it so not to lose it. And on Mac, it's Command S. I'm sure on PC, that's Control S, just to save it. Then we can go through the frequency tables. So what this is, let's run it first. Okay, so what it does, this line, is creating variable called myTable1. That's a random thing that I thought of. Then there's a table command, and what I'm doing is I'm creating a frequency table from my new data file, column shape and column year. I want to see them. So to see it, I just call this the same, and it will output it here. You can see it by the years, and so the x-axis is the year, and y-axis is the my shape, all the shapes that are in the data file, and you can see how many there are. So you can see that in 1991 there was 6 cigar shapes. In 1992 there were 10 of them. But make sure to know that as you go through the shapes, you know that some people are not consistent, so they might have typed cigar differently, or they might have said cylinder or something else. So this is not an analysis that you should rely on it too much, because you don't know how they typed it up. It's a user input information. This data file comes from user input, so they could have typed whatever they wanted. So once you do that, we want to see our bar plot based on that information. As you can see, these are all our shapes, but there are more bars than there are titles. And the reason being is my window is too small for that to show. So you can zoom right here, and you can see it, and you can drag it over, and you'll see more titles will appear. my window is still small, so you can't see all of them, but this gives you some idea. You can drag it bigger if you want to and see it better. Then you can close it out and it won't disappear, it's right here. If you want to clean this plots window and not have anything, you can do clear all. If you ever clear all in the environment, it will delete all the reading data files, which means that RStudio will not understand your commands because it doesn't have the data files read in yet. So whenever you do the clear, you have to run the script again. Okay. So next, we want to do a bar plot. So we want to see there are different packages to show anything, to graph anything. There's a very good one called ggplot. It's very pretty and it's very sophisticated because it, even though R is free and RStudio is free, a lot of people work on ggplot packages. Therefore, it's more developed. So to see this, we read in the library. Then we do this, which is creating a little variable and selecting only 1 through 100 rows of our new new data file, because otherwise it would be just a big mess if we read in all the rows. So we just select a certain portion. You can change this to whatever you want. You can make it 200, you can make it whatever you want. It will understand because this first it says where to start, the first row, and how much to go to 100. Okay, this is called subsetting, by the way. Then you run this code to draw it, and you can see it's running again, and there you go, new graph. This is showing you year 1993 because the first 100 rows had only all these years, and it shows the states by the color coding, and you can see how much of that have appeared right here. So we'll skip the next one. We can also do the box plot with this. It's using again our data file. Then next, we can do a pie chart. As I said, if you try unique shape, like we tried unique states, you'll see that there are these many unique ones. There's one that's empty, so somebody just left it empty. And there's some unknown. There's some like 3 dots as a shape. So going back to this code, we require this library. We can also do just library instead of require. It's the same way. Then we create this table, which is the based on the shape, and then we can do the pie. So we want to see all the. This is how to draw a graph, a pie graph. You say which data file, and then the radius, and then the density, angle information, and then the title of it, as you can see right here. Again, this is a little bit messy because it's small for my window. If I make it bigger, it will just change up and show you all the little titles. But you can see the biggest one, report is light. Then there is a lot of unknown, a lot of triangles, a lot of circle, disk. You can explore it on your own. Then we skipped the rest of it because we didn't have much time. I will save this data file, close it out, and go to the next one. You do the same, but make sure if you're saving, it's in your folder, not the folder that I shared with you. Okay, so you go to the next one, you click on this icon again, and you choose the one that says Numeric. You enter. So what this data file does, what this script does, is pretty much your homework that you were supposed to do with the New York data set. So the first step is the same, we already did it, and we have the session set working directory to source file location already done, but we will just repeat it just in case if you closed it out. Then we need to read this package in. Again, say no. For some reason, this is not working. If that gives you plus signs, that means it thinks that the script is not over. Therefore, you need to just do escape and then check your code. Everything looks correct, but I'll just select it all and then run it. Okay, it worked this time. Just wait until it reads in everything. And then once it gives you this note, it means packages are in. You're good to go. So now let's clear everything up from the previous one. Even though we can leave it, it doesn't matter as long as the data variable names are different. But I just want to start from clean slate. So clean it, then read in this file, and let's clean this as well. Then once the data file is in there, you can see how many observations and how many variables there are. We attach the file. Then we go to step 4. So in the step 4, and first part of the assignment was to create age groups based on the age column. We wanted to have groups that starts from infinity to 0. Then we had from 0 to 18 and to 24 to 35, 34 and etc. Until it got to 64 and 64 and 65 and above. So we just create this breaking point with the cut function. This is, like I said, it's already a function created by a certain package, so we don't have to code it. It knows what exactly it needs to do if given the right parameters. And to know the right parameters, you go down here and you do question mark, and you can do cut, and it'll tell you what you need to have in there. Cut requires, the required one is this X, which is the column name. The rest of it is optional, but you can see what X is, what the rest of it can be, and then there are some examples at the bottom. This is really easy to go through, and this is the help. So go back to the step 4. We created this, and now we want to look at it. You can see this is the age column that we had initially, gender, impressions, clicks, and sign-ins. So to see if this actually ran, oh, we didn't run it. Okay, after running it and doing head, we can see we have a new column, this age group, based on this age column. So 36, age that was reported in the row 1, it's between 34 and 44. That's correct. And then 73 is in 64 and above. You can just double check in the first couple of rows if it worked. So now you can see the variable number changed from 5 to 6, which means we appended a new column to our data file. So go to step 5, read in these libraries. Read the first one again because it gave you like a little arrow. Okay. So now you're creating a function which says, I'm going to take whatever you assign me to look into length, min, minimum, mean, and max. So now you run it, and you can see the output. As I said, the first one is length, then min, then mean, and then max. You can see it right here. Fun 1, fun 2, fun 3, fun 4. And this is your age group. It is based on the age group. So you can see that in the age below 0 and to 0, there's this many observations. So there are so many rows we have a weird age group, or 0, which is incorrect, and we are not interested in that one. And then you can see the minimum is 0, maximum is 0, and the mean is 0. Okay, step 6. Okay, now you can see the clicks, the information with the clicks. In the age group of this, there's as many. There's a minimum of, the minimum is 1. And then mean, impressions mean is 4.9, and the clicks mean is 0.13. So you have all your first columns. That was gender, signed in, impressions, and clicks. We saw it right here. And you have the mean of all of them. Okay, so now we go to step 7, reading the ggplot, and this is already, you're familiar with this one. This is going to draw you a nice little graph for your data. Look at this one and try to interpret it. I will help you. The x-axis is the impressions from the dataset, the column. Y-axis is the count, frequency. And you have color-coded the age groups. So this shows like the frequency of the impressions based on the age groups. Another graph would be box plots. You can see again the color coding is based on the age group, but here the x and y axis have swapped. You have impressions in the y axis, the number of impressions, and then you have age group at the bottom. So step 5 creates a new column in the data set that's called has int, which is has impressions or not. So we just created it, and you saw the variable number changed from 6 to 7. And then you can do a plot with ggplot of different things. And you can zoom in and take a look at it and try to interpret it on your own. Why is it that there is so much on the 0? And this is the density, and this is clicks impressions by the age group. Check out the age group. Then there are a lot more graphs. Every single line is a new graph. You can see it starts with ggplot function. So you can go through it on your own and see the graphs and try to interpret them. And then go to step 9, step 10, and step 11 on your own. We did not cover this in the class because we didn't have much time, but just go through it and try to understand it on your own. There are comments here to make it clear for you. So if you have any other questions, please let me know. But for now, I think this is it.